Hey guys, so today we'll be covering how to solve for the distance between 2 points, also known as solving for the length of a line segment. Now, there are technically a few ways to solve for these types of problems. I'm going to be covering how to solve for the length of a line segment just using the graph, just by counting on the graph, and then how to solve for the length of a line segment using the coordinate points. So here we have our very basic scenario where they give us a line segment on some coordinate plane, and we just need to find how long this line segment pretty much is. Now, if we do not know what the distance formula is, then we need to use our previous knowledge to figure out the length of this line segment. Now, I know back in middle school, one of the formulas that we used to solve for missing length was the Pythagorean Theorem, specifically for right triangles. So let's write that down. So the Pythagorean Theorem, I'm just going to shorthand this, used for right triangles was the following formula: a squared plus b squared equals c squared. Now, since it's used for right triangles, well, I don't have a right triangle, but I can actually draw a right triangle in, right? This is the great thing about geometry. We can construct additional figures in what we're given that can help us. You never want to construct anything that will make things more difficult. So in order to create a right triangle, I just need to add 2 more sides, and I want to make sure these sides meet at a right angle, and that would be a vertical and a horizontal side. Those will always meet at a right angle. Alright, so in this scenario, I need lengths to represent AB, not C, because C is going to represent my slanted side or my unknown side. So I'm going to call that C. So let me just call these legs A and B. Now again, in this simple scenario, I can actually just count the units. 1, 2, 3, 4, 5, 6 for that. And then 1, 2, 3, 4, 5, 6, 7 for that. So since I have 2 sides now, I can plug them into the formula, and I'll get the following. So my A is represented by 6, so that's going to be 6 squared plus 7 squared equals c squared. I have nothing for c at the moment. 6 squared is going to be 36, 7 squared is going to be 49, equals c squared. If I add these two up, 36 plus 49, that's going to be 85, equals c squared. And what you want to do at this point, you want to get your calculator, because you need to solve for the value of c. Now, if we have c squared, we need to perform its inverse operation, which is square rooting. Okay, so we need to square root c squared to get c. Okay, with that in mind, on this calculator, you're going to do second x squared, type in 85, press enter, and I have this decimal value. I'm going to round to the nearest hundredths place, so that's 9.22. And that was pretty much it. You know, using what we previously knew, we were able to figure out this new scenario. But again, that's just using the graph. Let's say we are in a situation where we have to use the coordinate points, and there are going to be plenty of times where they just give you coordinate points, no graph, and you either have the option of taking the time to graph the line and then draw the right triangle, or using this alternate formula of the Pythagorean Theorem. So the first thing you want to do is identify the coordinate points. So let's first identify B, and that's going to be 9, 9. Let's identify A, which is 3, 2. And let's also identify this point of intersection, which is going to be 9, 2. And that's going to help us create a general formula for solving for the distance between 2 points on a graph. Okay, so the first thing we did after we created our right triangle was that we found the length of the horizontal line and the vertical line. Well, in this case we can count, but if we're given coordinate points, well then counting won't help. We have to use those numbers to help us figure it out. So we know that the length between the distance between these 2 points is 6. We know that this x value is 9 and this x value is 3. Well, how do I get 6 from 9 and 3? I can subtract. So here I'm going to write, well, in order to get my x value, I did 9 minus 3. Okay. Same thing for the y's. I focus on the y values. There's a 9 here and there's a 2 here. 9 minus 2 does give me 7, so that is definitely going to work out. Okay, great. So let me just add those as 6 and 7. And we see that these are the same values that we plugged into our Pythagorean theorem. So we're good to go. Alright then, so let's generalize this even further. I'm going to label these coordinates with the x1, y1. So x1, y1 here. This is going to be my x2, y2 here. Now this coordinate point that we created is a combination of these 2 points. This 9 came from x2, and this 2 came from y1. Now we see here that we were subtracting coordinate points. So in a general scenario, in any coordinate points that were given, if we're ever trying to find the length of the horizontal part of our right triangle, we just need to do x2 minus x1, the 9 minus 3. So x2 minus x1. Main mistake here, don't ever write it like this, always put it as a subscript. Same concept for the y's. We're going to do y2 minus y1, 9 minus 2, y2 minus y1. So now, if we were to plug these into our Pythagorean theorem, remember, this x was our a, so this is for our a. This y was our b, so this is for our b. We're going to change this a squared plus b squared equals c squared to x2 minus x1 squared plus y2 minus y1 squared equals c squared. Okay, so we can actually plug these values in and double check to see if it's the same thing. Well, I know x2 minus x1 was 6, so I have 6 squared plus y2 minus y1, that was 7. And look, we end up in the same situation we were in when we just used the Pythagorean theorem as it was from all that counting and whatnot. So 6 squared plus 7 squared equals c squared is, I'm going to skip all those intermediate steps, is again going to be 9.22. Right? So this is a very general way of expressing what we call the distance formula in order to help us to solve for the distance between 2 points. Now, when you search up the distance formula online, you won't see this version, you'll see this version. So I'm going to rewrite it down here. And then, instead of having c squared, I'm going to take the square root to both sides because I just want c by itself. So you're actually going to end up with the final version of, make sure this is in the camera, you're going to end up with the final version of this. Square root of x squared minus, x2 minus x1 squared plus y2 minus y1 squared gives us c. Sometimes they call it d for distance, so this actually ends up being your final product. This is the general distance formula that you see if you were to search up online or in any textbook. But if we look back, it's really the manipulation of the Pythagorean theorem that gives you the distance formula. So the Pythagorean theorem can be used really for any length in space, used with or without coordinate points. I'm just going to abbreviate it, with or without coordinate points, but this distance formula here, this distance formula, has to use coordinate points. Okay? And that's pretty much it. So, using the Pythagorean theorem as it is really for special cases, like with whole numbers and maybe workable fractions. But when you deal with irrationals, God forbid, square roots, then you would definitely go to here. This will always give you the correct answer if used properly. And that's pretty much it. So if you guys have any questions or comments, leave them in the comment section below. Like and subscribe. Feel free to message me for requests of additional topics or to further elaborate. I will be working on problems that require the distance formula, so you'll definitely get to view that practice as well. Alright guys, have a great day. Bye!